Hello, it's Mr. Hogan here. I'm talking to you today about the division of complex numbers. By the end of this presentation, you should be able to identify the conjugate of a complex number, identify the inverse of a complex number, use conjugates to divide complex numbers in Cartesian form. Okay, what do I mean by a complex conjugate? Two complex numbers are conjugates if when you multiply them together, they give you a real number. Let's have a look. Here's a complex number in Cartesian form, x plus yi. Z equals x plus yi. Then its conjugate is z bar equals x minus yi. You'll notice that z with a bar on the top is the symbol for conjugate, and we call that z bar. Okay, let's try. Here's a complex number, 2 plus 3i. Its conjugate is 2 minus 3i. Let's try again. Here's 4 minus 7i. Its conjugate is 4 plus 7i. And one more. If z equals minus 2 plus 5i, then its conjugate is minus 2 minus 5i. Okay, here I've got two complex numbers, and I'm trying to multiply them together. These are conjugates, z plus 3i times z minus 3i. And you'll remember from earlier on, first times first, outside by outside, inside by inside, last by last. And that gives us 4 minus 6i plus 6i minus 9i squared. What does that look like? Well, minus 6i and plus 6i cancel each other out. We're left with 4 minus, but remember I squared equals minus 1. So 4 plus 9, 13. So we've multiplied two complex numbers together, two conjugates, and we've ended up with a real number. Okay, here's an interesting thing. With multiplication, does it matter if I do the work out the conjugates first, or do the multiplication first and then take the conjugate? Let's find out. If z equals 2 plus 3i and z2 equals 4 minus 7i, z1 times z2, we're just going to do this first by first, outside by outside, inside by inside, last by last, and we come up with 8 minus 14i plus 12i minus 21i squared, which gives us 8 minus 2i plus 21, 29 minus 2i. Now let's take the conjugate of that, becomes 29 plus 2i. Let's try it this time using the conjugates first. So I'm using, notice, this time I'm using the conjugate of z1 and the conjugate of z2. We follow the same process. 8 plus 14i minus 12i minus 21i squared gives me 8 plus 2i plus 21 gives me 29 minus 2i. What's that telling me? They're both the same, so in this particular case the answer is yes, they are equal to each other. Okay, let's look at the inverse law. This is one that we're going to use when it comes to division. The inverse of a complex number, z, is 1 over z, which is 1 over x plus yi. Now, you'll note we don't like to have the I in the bottom line. The I is the square root of -1, and you'll remember from your earlier work, we don't like to have the square root. We like to rationalize the denominator. How do we do that? I'm going to use difference of two squares. That is, I'm going to multiply by the conjugate. If I multiply the bottom of the fraction by the conjugate, then I have to multiply the top of the fraction by the conjugate. X plus yi, x minus yi is a difference of two squares. That gives me x squared plus y squared, and whatever I get on the top line. We're going to use that for division of complex numbers in Cartesian form. We're going to use that difference of two squares, and we're going to multiply and divide by the conjugate of the denominator. So here's my example. 3 minus I divided by 2 plus 3i. What do? I multiply by the complex conjugate of the denominator. So you'll notice here, I'm multiplying by the conjugate of the denominator, top and bottom. Remember, little trap for young players, if something's on a division sign, it's the same as having brackets around it. So this is the same as having all of these in brackets. So first times first, outside by outside, inside by inside, last by last. That gives us 6 minus 9i minus 2i plus 3i squared, all over 2 squared minus 3i squared, which gives me 6 minus 11i minus 3, all over 4 plus 9, which gives me 3 minus 11i over 13. Now that's our answer. However, there are a couple of different ways of writing that. In some texts you'll find it written where they break it into the real part. So we have our real part of z here, and our imaginary part. And in other texts they take out the divisor as a common factor. You need to be familiar with both ways of writing. Okay. By the end of this presentation, you should be able to identify the conjugate of a complex number, identify the inverse of a complex number, and use conjugates to divide complex numbers in Cartesian form.